To my channel. My name is Arun. I'm Solutions Architect MCT, currently working with Novintech, which is one of the best organization to work with. And today we are going to explore the capabilities, the features of MS Defender Vulnerability Management or DVM. So let's start. We have a list of features, as you can see, which are there or provided by DVM. These features we have seen in our previous video as well here. If you remember, I showed you this link where we have all those features, and as per the plan and the add-on, these features will be applicable to you. So we are going to explore each and every feature that is listed here in today's video. All right, so let's start with the device discovery today. So what is device discovery? So device discovery helps us find the unmanaged or unknown devices which is there in our network, which are not yet onboarded to the Defender, which means there are resources which are not visible to us or there in our environment, but we are not aware about them. So those are unmanaged. And the devices which we are aware of are the managed ones because the sensor or agent is already been installed on it, and those are visible on the Defender portal. So how come this device discovery happens then? Because if there is no agent installed, because of network signals. This DVM device discovery uses network signals, authenticated scans, and its integration with endpoint sensors. All those things will help identify all the devices in your environment. And that's the reason it will figure it out those devices IP address or the host name of those devices, OS fingerprint, etc., which are there in the environment but not visible on the Defender. So that is device discovery. Now, how it helps us? Well, it eliminates the blind spots, which means what? Because attackers often target unmanaged devices because managed devices have already been secured, right? So unmanaged devices are lack of security. They are not secure, they are lack of security, so easily hacked or targeted by the attackers. So discovery ensures you know every asset in your environment, not just the managed ones, right? Then it helps us onboarding the gap closure. What does this mean? It is closing the gap. Many organizations think all devices are protected, right? Because if you are a big organization and on Defender it shows number of devices, you will think all are protected, all devices are available. Nobody is going to check one by one, or nobody is going to check that. If the devices or maybe the people are just hooking up their devices in the corporate network, their own BYOD kind of thing, right? So until device discovery happens and it shows otherwise, people think their whole environment is protected. This will be the reality check whether it's protected or do we have unmanaged devices. So it helps IT onboard missing devices into Defender and apply the policies. Now, just like any other server machine we're talking about, same goes with the IoT and rogue device visibility, which means this can even find devices like smart TVs, printers, or personal laptops connecting to the corporate networks that you can ignore it or take the necessary actions. Do not ignore it. So these can be risks if unmanaged and could make your environment vulnerable. And it is a vulnerability management, right? Yes, and compliance and asset accuracy because security frameworks, because we manage security frameworks or the organizations which are like established organization, they have to go through certain frameworks, and this will help them manage their compliance like CIS or NIST or ISO 27001. those kind of things. Device discovery, you could say, is the first step on a reliable CMDB, and all devices are managed. If the discovery is not happened, you cannot say with confidence all devices are managed. You might find unmanaged devices somewhere. So this DVM, vulnerability management first feature, device discovery, will help you do that. So how can it help? Let's suppose there is a they are old devices, some Linux VM, or maybe a developer connects a personal VM to the corporate network for testing. So it's not managed, it's unpatched, and it gets infected with malware, which spreads laterally. If it's not discovered, or if you are using without DVM, without device discovery. But if there is a device discovery enabled, DVM flags the unmanaged Linux VM or unmanaged laptop or old VM in your environment as a newly discovered or unprotected device, and IT either onboards it or blocks it from the network, prevents the malware from spreading through the shadow IT device or legacy thing or something like that. So you got the idea, right? There was device discovery. So in a nutshell, device discovery in DVM helps organization identify unmanaged, rogue, or forgotten devices, right? Which devices? Unmanaged, rogue, or forgotten devices, ensuring they are onboarded, secured, or isolated or blocked, closing blind spots and reducing the attack surface. That's how it helps us, device discovery. Now let's go to the second feature, which is device inventory. So what is device inventory? Well, this feature gives you a complete centralized view of all devices and configuration environment that are onboarded. So if you are asking what's the difference, device inventory and device discovery both seems like the same thing. Look, this highlighted, the bold word is the keyword. Only it will give you the centralized view of all devices and their configuration only of onboarded devices. It will not give you information about the unmanaged devices. That's the key difference. But this is needed. Inventory is needed. That's the reason. If discovery figures out there are few devices which are not onboarded, we will onboard it, and then it will appear in the inventory, and we have the complete visibility of the environment. So many organizations don't know exactly how many devices are in use, especially with the remote work or bring your own devices. Device inventory ensures a single pane of glass view, right? Centralized view. So why do we need it? First of all, complete visibility. As I said, your organization doesn't have or doesn't exactly know how many devices you have, but this centralized view will help you have a complete visibility. And this device inventory ensures a single pane of glass view. You can go to this and see all the devices in your environment. Identify unprotected devices. Now, inventory also identify unprotected devices, because devices missing the defender agent, missing EDR, or out of compliance can be spotted quickly and helps IT close coverage gaps. It supports vulnerability prioritization. It supports vulnerability prioritization because each device is tied to its vulnerabilities and misconfigurations. So it makes easy to see which device are highest risk and prioritize. We have talked about this in the previous video, prioritization. And finally, compliance and asset management, because auditors often ask for proof of managed assets. Device inventory doubles as a real-time CMDB, right? Configuration management database for security posture. So DVM, you can rely on DVM device inventory because you know all are onboarded and managed devices. So let's suppose, just in order to understand it better, let's suppose there is a forgotten legacy server in a test environment and is still live but unmonitored. So it runs an old OS with critical vulnerabilities. Attackers discover it and use it as a weak point or pivot point. So if you use DVM, DVM lists the test server as high risk unsupported operating system, Defender not running, or it either patches, isolates, or decommissions it. So it prevents an unmonitored backdoor into the corporate network, right? So that's how this helps. So if we need to conclude this, what is device inventory in DVM? Well, it ensures organizations should have a full visibility into every device, its security posture and vulnerabilities, helping eliminate blind spots, reduce attack surface, and improve compliance. Now let's quickly jump to the third, which is vulnerability management. So what it is? Well, this is a core function of DVM. This is the core function of DVM because it identifies, evaluates, and reports software and system vulnerabilities across endpoints and servers. And what are vulnerabilities and things like that, we have already covered here in the previous video. Vulnerability management, the entire overview, we have covered it already in the previous video. Here we are understanding all those features. So we know what is vulnerabilities, and vulnerability management will help us to manage those vulnerabilities, fix those things. So how it helps us? It scans for missing patches, insecure versions, and unpatched CVEs. That's how it will help us manage. So it uses Microsoft threat and vulnerability intelligence to enrich findings, provide insights into exploitability, affected devices, and remediation options. So that's how it helps us. So why do we need it? To reduce the exploitable weaknesses. Most cyber attacks begin with exploiting known vulnerabilities, and this is vulnerability management. So before attackers will exploit it, you will fix it because it will tell you. So regular vulnerability assessment ensures weaknesses are found before attackers can use them. Then it will help you prioritize patching efforts because it helps IT teams focus on critical vulnerabilities with real world exploit activity instead of patching blindly. It will prioritize which needs to be fixed first. We also covered this one in the previous video when we were giving information about this. The entire thing, if you have seen the previous video, you'll find it somewhere. All right. So, and compliance and audit readiness, because this is the same point which will keep on coming in every feature, because each and every feature will help us maintaining the compliance and audit readiness, which is one of the most requirement of enterprises organizations. And finally, continuous risk management, because unlike traditional periodic scans, DVM integrates with Defender sensors for near real-time detection. So real time, before attacker can attack you or exploit the vulnerabilities, you will be aware there is some kind of vulnerabilities and you'll fix it. Right. Let's take an example just to understand or cement the knowledge about vulnerability management. Let's suppose there is a workstation running Adobe Flash Player, which is Adobe Flash, which is like a end of life with unpatched critical CVEs. Attackers deliver ransomware through a malicious flash file. The vulnerability was never detected if you do not have DVM. But if you have DVM, DVM flags the Adobe Flash as end of life and vulnerable. With remediation guidance, you will uninstall or replace it. IT removes it across the endpoints. If you remember, we have also completed this piece here, right? Collect, assess, prioritize, remediate, right here. Remediate. If you see the pipeline, this will help us right here, remediate. All right, so this piece is done. We are good with it. Vulnerability management. Let's try. All right, let's try to summarize. We forgot to summarize vulnerability management. So vulnerability management in DVM gives organizations a visibility into unpatched software, insecure versions, and known CVEs, enabling them to patch, prioritize, and protect their environment proactively. That's what the vulnerability management is. Now, configuration assessment or configuration management. Configuration assessment, this feature evaluates the security configurations of Windows devices and compares them against Microsoft recommended best practices and industry standards. That's what it does. So it looks at the OS settings, policies, and services like firewall, RDP, SMB, local accounts. It identifies weak, insecure, and misaligned configuration, and it maps findings to frameworks like CIS benchmark, NIST, Microsoft baseline. That's what happens in Azure, like Defender policies. Those will run all the CIS benchmark initiatives, and it will compare what you have, and it will give you the recommendations. So what it will give you, it will give you the misconfigurations or easy targets, because misconfigurations are the easy targets. So most breaches exploit poorly configured settings like open ports, weak or local accounts, weak passwords, those kind of things, misconfiguration. So configuration assessment reduces this attack surface. So this is configuration assessment, not management. I wrote it wrong. It says configuration assessment. Just double check here. It should be assessment. Configuration assessment, right? It's my bad. We'll correct it. Right. But you got the point. It assesses and it will tell you the misconfiguration. As we give the example of MS Defender backed by the CIS benchmark policies initiative, and it will run, it will tell you all the weaknesses in your environment. Right. So how it helps us? Well, easy targets will help you. It will find easy target for you without assessment. Different departments devices may drift into different security postures, so it will help you standardize the across endpoints, so it ensures a consistent baseline across the enterprise. Compliance audit readiness, it's the same thing again. Then early risk detections, even if fully patched, a misconfigured system is still vulnerable or it could be exploited. So DVM catches these before attackers can exploit it. Right. So let's take an example to understand it. Finally, configuration assessment. Let's suppose there's a group of servers for has RDP enabled without network level authentication. Attackers exploit brute force logins and gain access if you do not have DVM. But if you have DVM, DVM flags RDP without NLA or network level authentication as a critical misconfiguration. Now it enforces NLA across all servers. Brute force RDP attempts are blocked, preventing unauthorized access. All right. So in short, configuration assessment in DVM continuously checks for what? Checks for misaligned, insecure, or risky OS configurations and ensure your devices follow secure standard policies, reducing attack surface and supporting compliance. Right? So that is your configuration assessment. Then we have risk-based prioritization, which means this feature helps organization decide which vulnerabilities to fix first by ranking them based on the actual risk instead of just severity. All right, if it's a huge environment, you can have number of vulnerabilities, but you should know which needs to be fixed first. Right. So traditional vulnerability management often prioritize using CVSS scores only, but DVM enhances this with real world exploitability, business context, and threat intelligence. It highlights vulnerabilities that are actively exploited in the wild or exposed on high value assets. Right. So that's how this helps you. So it avoid patch overload, which means thousands of vulnerabilities are discovered each year. Patching all at once is not realistic. So risk based prioritization ensures focus on the most critical issues first. Now, then faster risk reduction. That's how it helps us. Fixing 10 high risk exploitable vulnerabilities can reduce exposure more than fixing 100 low risk ones. So, faster risk reduction. It will help real world context. How? Because a CVE rated high by CVSS may not matter if it's not exploitable in your environment. DVM prioritizes based on exploit activity, malware campaigns, and attacker techniques. Real world context. Finally, business alignment, because prioritization also consider whether the vulnerability is on a critical server, which is like crown jewel asset or internet facing endpoint, making remediation decisions business driven. So that's how it helps risk based prioritization. So if you do not have that, then your IT may see 200 vulnerabilities flagged. They start patching from the top of the CVSS list. A medium CV left unpatched but actively exploited in ransomware campaigns leads to a breach, because you are still, this is more like everybody is running in all the direction to fix it. But DVM, if you have DVM highlights the medium CV is actively exploited in the wild and exists on a domain controller. It's ranked as a top priority. So follow DVM, fix all those top priorities, and it will help you faster risk reduction along with real world context. And it will avoid patch overload because it gives the business alignment as well. So, in short, risk based prioritization in DVM makes vulnerability management smarter and business aligned by using threat intelligence, exploit data, and asset value to decide what to fix first, ensuring maximum risk reduction with minimum effort. All right. Okay, then let's go to the next one, which is remediation tracking. So, what is remediation tracking? Well, this feature lets security and IT teams assign, monitor, and verify remediation actions for vulnerabilities detected in the environment. Vulnerabilities found in devices, applications can be converted into remediation task. Okay, remediation task. These tasks are integrated with Microsoft Intune Endpoint Manager or ITSM tools. So the dashboard provides status tracking, open, in progress, resolved, and overdue. So this is remediation tracking because you should track it, otherwise you don't know whether it is fixed or not. So how it helps? Because it bridges security and IT teams. Security teams identify vulnerabilities, but patching is usually done by the IT ops team. So remediation tracking provides a clear workflow to assign responsibility and deadline. It ensures accountability because every remediation task is traceable with assignee status and due date. Helps avoid the identified but never fixed problem. So fast risk reduction. How come it's fast risk reduction? Because by tracking tasks in real time, teams can quickly see which critical vulnerabilities are pending and prioritize them. And finally, compliance and audit readiness, because it is there everywhere. It provides an audit trail for regulators showing vulnerabilities were identified, assigned, and resolved in case of remediation tracking. So, how exactly it is helping us? Let's take an example to understand it further. So, let's suppose there is a security reports 50 endpoints missing a critical Windows patch. IT acknowledges, but due to lack of tracking, 10 devices remain unpatched. That's what happens if you don't track it. So a breach occurs on one of them and nobody is happy then. So what's the solution? Get DVM, because DVM automatically creates a remediation task for IT in tune with a due date. The dashboard shows progress 40 devices patched, 10 pending. Alerts notify IT before deadline, and all devices patched in time, vulnerability closed, and audit logs available for you. Happy compliance, happy IT folks. No night calls. So, in short, remediation tracking in DVM turns vulnerability findings into actionable task, tracks their progress, and ensures accountability between security and IT teams, reducing risk faster and providing compliance. All right, then let's go to continuous monitoring. So this feature ensures that vulnerabilities, misconfigurations, and security gaps across your devices are continuously tracked in near real time. Continuously tracked in near real time. Continuously tracked in near real time. Instead of being dependent on periodic scans. So that's the key. What's the key? Continuously tracked in near real time. So it uses Defender sensors already present on endpoints, no heavy scanning agents, lightweight. We talked about it in previous video. So it monitors operating system, applications, configurations, certificates, hardware, firmware state, provide up-to-date risk exposure in the DVM dashboard. So, how it helps? Faster risk detection, because traditional vulnerability management tool rely on scheduled scans, and this is happening near real time. So, faster risk reduction. Continuous monitoring ensures that as soon as a new vulnerability appears or a misconfiguration happens, it's detected. Then proactive defense. Threat actors exploit new CVEs within hours or days of disclosure. Continuous monitoring helps close the gap between vulnerability disclosure and remediation. Ongoing compliance. Compliance comes everywhere. So many frameworks like CIS, NIST, PCI requires ongoing monitoring rather than one-off assessment. So it's there for you. Continuous monitoring satisfy these requirements. Supports zero trust, which is there everywhere. Zero trust security. So security posture changes constantly. New apps installed, configuration modified, certs expiring. So continuous monitoring ensures no drift goes unnoticed, right? Then, in the end, let's take an example just to understand that we understood it correctly. So, a new critical Chrome vulnerability, let's call it 0 day, is published on Monday. The next scheduled vulnerability scan for us may be Friday. So, attackers exploit the gap because they start in couple of hours or a day. So, they have enough time to kill it. So, compromise multiple endpoints before IT even take any action or even know. So, what's the solution? DVM is your friend. DVM continuous monitoring detects unpatched Chrome version across endpoints on Monday itself. Within hours of disclosure, IT pushes emergency update immediately. So, exploit window is closed before attackers can act. So what is continuous monitoring? It's continuous monitoring in DVM gives you real time visibility into vulnerabilities and risks across your environment, ensuring faster detection, quicker remediation, ongoing compliance, and a stronger security posture. Very well. Let's go to software inventory. We talked about device inventory. Now it's software inventory. What is software inventory in DVM? This feature provides a comprehensive catalog of all software installed across your Windows devices. Isn't this wonderful? Everybody needs it, wants it. What is installed? Who is using? What is in use? So it lists applications, versions, publishers, and installation dates. It maps applications against CVEs, known vulnerabilities. It enables filtering by application name, version, vendor, or device scope for investigation. So how it helps? Because of complete visibility you are getting inside the devices. Now many organizations don't know what's installed across all endpoints. Software inventory ensures IT security has a single source of truth for installed applications. So you're getting complete visibility. Now, identify vulnerable applications because it's getting software. So, by correlating with CV databases, DVM flags applications with known vulnerabilities. Example, an outdated Apache Log4j library installed on dev servers. You got it? All right, then remove unauthorized or shadow IT. Employees often install applications outside IT approval just to make the things easy. Call it shadow IT. All right. So inventory helps find it and remove them because the intention is not to invite attackers. Intention is to make the job easy, but the side effect is it will invite the attackers. So you need to remove them. And compliance and licensing. Regulatory audits like PCI, ISO, HIPAA often require proof of controlled software usage. Inventory supports software license compliance by tracking actual deployments. So that's how it helps us, and that's what it is. Now, take an example just to understand if we understood it correctly. So, an old version of WinRAR with a known CV is installed on multiple PCs, but IT is unaware because it wasn't part of the standard image. So, attackers exploit it through malicious RAR files. They can, right? So, what will you do? Well, before we reach there, we will go with the DVM. DVM shows WinRARs, whatever is installed on 12 devices, maybe, and flags it as vulnerable. IT upgrades or removes it immediately. Exploit path is eliminated before attackers can use it. So, what is software inventory? Software inventory in DVM is the foundation of vulnerability management. It gives all or full visibility into what's installed across your environment, helping detect vulnerabilities, control shadow IT, and support compliance. All right, then let's go to software usage insight. Don't we want it? Software usage insight. This feature goes beyond inventory. What software is installed and tells you how software is actually being used in your environment. If you know, you can save a lot of money too, right? Not just saving the attackers. All right, so it monitors application launch events, frequency of use, and user activity. It highlights rarely used or unused application. For example, you have 100 cloud engineers and 10 architects, and maybe you are paying for 100 licenses for Visio, like software to draw. But if you have this insight, you can save the money, right? That's what I was talking about. Everybody is not using it, but everybody has it, so you're paying for the licenses. Anyway, so it helps. That is the secondary thing. We have precisely talking from the security perspective. So it highlights rarely used or unused application, which means it helps identify risky application that are used heavily but may have vulnerabilities. So why do we need it? It reduces attack surface. How? Because if software is installed but never used, it still creates potential vulnerabilities, right? Removing or blocking unused application reduce exposures for sure. Now, prioritize the patching by usage. Not every application needs urgent patching. We have already talked about it. So DVM helps prioritizing patching high usage app first since they carry the most risk if exploited. Then optimize licensing cost. Many organizations overpay for unused or underutilized software licenses. As I was talking at the beginning, I got excited because before this video, I was working on some cost optimization project. So it just hit it, right? So we have already talked about optimizing licensing cost, then support IT governance, visibility into what employees are actually using, prevent shadow IT, which is something needed, right? Now let's take an example just to understand that we understood it correctly. So the company has Adobe Acrobat Pro installed on 300 endpoints. Only 40 employees actively use it. And unpatched Acrobat vulnerability exposes all 300 machines to risk. Plus the company wastes money on 260 unused licenses. See, money, money, money. So what should we do? We should use DVM. DVM reports that only 40 users actually run Acrobat Pro regularly. Of course, IT patches those first and removes the software from the rest of the machines. So security risk drops and license costs are optimized. There we go. Happy, happy, happy. Now, what is software usage insights? Well, software usage insight in DVM helps organization make smarter security and cost decisions by showing which applications are actually being used, enabling better patch prioritization, attack surface reduction, and license optimization. That's what it is. All right, then let's go to security baseline assessment. So, what is security baseline assessment? Well, this feature checks Windows device against Microsoft recommended security baseline. The same example I gave you earlier. The baseline will match through the initiatives, right? So security baselines are predefined sets of security configuration created by Microsoft, like password policy, BitLocker, firewall settings, RDP restrictions, all those things. So DVM automatically compares the current system configuration with these baselines. It highlights the gaps, misconfiguration, and deviation that weaken security postures. All right, so that's what the baseline assessment is. So how it helps consistency across devices, because large organizations often have thousands of endpoints without baseline. Each one might have different security settings, right? So baseline assessment enforces standardized, consistent security policies or posture. It identifies weak configurations. Even if a system is patched, misconfiguration policies like weak password length or disable defender can expose it to attack. So baseline assessment identifies these weaknesses. It supports zero trust and compliance because it aligns with CIS, NIST, and ISO frameworks. It helps meet compliance audit by providing devices follow industry standard security guidelines. It will give you all those recommendations, wonderful recommendation that you need to implement. And of course, continuous posture improvement. This is happen through the Defender. We all know posture management. So regular assessment allows IT security teams to track progress over time and measure improvement against a benchmark. So this is the well-known thing. We have talked about it many times. So just to understand that we get it right, what we'll do, we'll take an example. So a group of laptops in the finance department have RDP enabled with no lockout policy configured. An attacker brute force, what will it do? The RDP login, it will gain the access through the brute force. Yes, yes, yes. So what you'll do? You will not go without DVM. You want your DVM there. So DVM detects that the finance laptops deviate from Microsoft baseline. And what will it do? It will alert you. IT will remediate the configuration, attack surface is reduced, and brute force RDP access is blocked. All right, so that's what the security baseline assessment does. So, in short, what it is? Well, security baseline assessment in DVM ensures that all devices are aligned with Microsoft recommended security configurations, helping reduce misconfiguration, enforce consistency, meet compliance, and strengthen overall security posture. All right, then let's go to the block vulnerable applications. So, what is block vulnerable applications? Well, this feature allows security admins to proactively prevent execution of applications. Proactively prevent execution of application. What it is? Proactively prevent execution of applications that are known to be vulnerable, outdated, or high risk. That's why I block the vulnerable application because it proactively prevent the execution of applications that are known to be vulnerable, outdated, or high risk. So what it does, it integrates with Defender, MS Defender antivirus and attack surface reduction ASR. We talked about it, right? Based on threat intelligence and vulnerability data, DVM can block applications with known CVEs or poor security posture. It ensures that users cannot accidentally run unsafe application in the environment. So that's how it helps us. Prevent exploitation. Many attackers exploit unpatched applications like Adobe or Java in old browsers. Blocking these at execution prevents attackers from gaining an entry point. So, vulnerable applications block, block, block. Reduce shadow IT risk. Employees sometimes install unauthorized or outdated software. We all know that, but DVM enforces a safe application baseline by blocking insecure applications. Tata bye bye. Then contain malware spread. How it contain malware spread? Because vulnerable apps are common vectors for ransomware and Trojans. So blocking them reduce overall attack surface dramatically. Compliance and control. Again, it came here because many standards like CIS, ISO, NIST require organizations to limit or prevent use of insecure applications. It is there. It is there. You need to maintain it. How will you maintain it? DVM. DVM makes enforcement straightforward. There you go. So block vulnerable applications. So what we will do now, we'll take an example just to see we get it correctly. So a user installed an outdated version of, let's suppose, zip with a known remote code execution vulnerability, CVE, code execution vulnerability, CVE. An attacker exploits it through a malicious archive and gains control over the user's PC. That's what happened because it's a CVE vulnerable already known. So what is missing here? DVM. DVM is missing here. DVM has the outdated version flagged. If it would be there, it would have flagged the outdated version. When the user tries to run it, Defender blocks execution, preventing compromise. So attackers exploit attempt fails before it even starts because block, 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 block vulnerable application. So we're good with it. What is block vulnerable application in DVM? Well, it is a Microsoft threat intelligence and vulnerability data to stop insecure application from running, reducing attack surface, preventing exploit-based attacks, and enforcing secure software usage. That's what it is. Proactively prevent execution of application. Which application? Known to be vulnerable, outdated, or high risk. Those application. Very well. Let's go to browser extension assessment. We all know it's there. So this feature inspect the browser extension add-ons installed on enterprise endpoint for supported browser like Edge, Chrome, etc. That's what it is. So it collects the inventory of installed extensions. That's how it will know what's to block. So it checks whether they are malicious, vulnerable, outdated, or high risk. Collects, checks, and it identifies permissions requested by extensions. If the extension's asking for more, no, 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 it won't allow. All right, so how it helps control shadow IT in malicious extensions because employees may unknowingly install extensions that harvest data, inject ads, or steal credentials. DVM helps detect those and remove them quickly. It helps prevent data leakage because extensions fetching your data and DVM would not allow it, right? Compliance and governance, again, it is very important thing, right? Compliance and governance. So many regulations like GDPR, HIPAA, PCI require control over how sensitive data is accessed. Unvetted extensions can easily break compliance if they leak or misuse data. So it helps you manage the governance. And of course, improve the IT visibility because without monitoring, IT teams often don't know what extension employees are using, and DVM gives a centralized view to approve, block, or restrict the extensions. All right, then let's try to understand with the help of an example. Did we get it? Let's suppose there is a user who installed a free PDF converter, a Chrome extension. It requests access to all websites visited. It silently captures corporate login sessions and exfiltrates data to an attacker's server. No, 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 we don't want that. So, what we need DVM. DVM flags the extension as high risk. It will see malicious extension, it will see data leakage, and IT is alerted and removes it across all endpoints, so prevents a major data breach caused by a seemingly harmless extension or add-on, right? So what is extension assessment? Well, browser extension assessment in DVM gives enterprise enterprises visibility and control over browser add-ons, helping to block malicious or risky extensions before they can compromise users' data or sensitive data or data leakage. Very well, then let's go to digital certificate assessment. So, what is digital certificate assessment? This feature evaluates the digital certificates installed on Windows devices, both system and user level. So, it checks for expired, weak, or soon to expire certificates. It identifies certificates using weak cryptographic algorithms like SHA-1 or RSA with insufficient key length. So it supports untrusted or self-signed certificates. It's not support, it spots. It spots untrusted or self-signed certificates that may allow attackers to bypass security or perform MITM, man in the middle attack. That's what it is. So how it helps? It prevents service outages because expired TLS means service has gone, or code signing certificates can suddenly cause outages. We don't want that. So DVM proactively warns before expiration so IT teams can renew them on time or in time. Strengthen the security. Of course, it is strengthening the security because weak or compromised certificates allow attackers to impersonate trusted services, and DBM ensures only strong trusted certs are used. Again, compliance is there because regulations like PCI or NIST require proper certificate lifecycle management, and certificate visibility is a key requirement for audits. And it reduces MITM, man in the middle malware risks and malware risk. Attackers sometimes install rogue root certificates on endpoints to intercept traffic. DVN can flag these so they can investigate it and removed. So that's what the digital certificate assessment is. It's time for understanding correction. Let's take an example. A web application's SSL certificate expires unexpectedly. Users start seeing browser warnings and can't log in securely. IT scrambles to fix it after downtime has already hit. How can we avoid it? DVM, because DVM flagged the certificate 30 days before expiry, alerting the team to renew it. Right? Service runs smoothly with zero downtime and no security warnings for users. And if anybody using anything else or weak, will also get highlighted. Let's go to network share analysis. All right, then. Okay. Network share analysis. So what is this? This feature inspects the shared folder. What it inspects? Shared folder. and network drives across the Windows devices. What is network drives? Shared, right? Shared folder network drives across Windows devices in your environment. Well, it identifies the insecure or overly permissive share configurations, like everyone, full control. Everyone has the control on these files like that. So it detects anonymous access or weak access controls on shared resources. It helps assess exposure of sensitive data that may be accessible over the network. That's how it helps us. So, why do we need it? Because attackers who compromise one device often took for open network shares to spread malware or ransomware. So, reducing the lateral movement risk. Misconfigured shares are a common way ransomware encrypts file across the organizations. Lateral movement, we don't want it. And it will help us. And prevent data leakage because sensitive files like HR records, financial data, or source code should not be placed in publicly accessible network shares. So DVM flags shares where unauthorized users may access critical data. Compliance and data governance because frameworks like GDPR or HIPAA or ISO 27001 require data access control. Insecure shares can be a violation. And operational hygiene because many organizations accumulate forgotten shares that are still accessible but unmanaged. Network share analysis helps you find those and clean them up. So that's what the network share analysis is. Now let's take an example. There's an old finance share. Whack whack server 01 whack finance is configured with everyone read write. An attacker gains access to a junior employee's device and immediately writes ransomware to that share, encrypting once of financial reports, and then it's a bad thing for the organization, right? So what you need DVM. Why? Because DVM flags the finance share as overly permissive. Everyone has right access. And we don't want lateral movement. So IT restrict it to a dedicated finance group, least privilege principle. This removes a lateral movement path and prevents ransomware from spreading across departments. So, network share analysis and DVM detects misconfigured, exposed, or insecure network shares, helping organization protect sensitive data, reduce ransomware spread, and comply with governance requirements. All right, then we are here, almost there. Second last, hardware and firmware assessment. Yes, that's a feature. And this feature checks your device at the hardware and firmware level below the OS, right? Firmware, hardware, and OS. It looks. How? Because it looks. Where it looks at the BIOS, UEFI firmware version, drivers, and critical hardware components. It identifies known vulnerabilities in firmware or hardware, for example, Intel, AMD, CPU vulnerabilities like Spectre, Meltdown, or insecure firmware versions from Dell, HP, and Lenovo. It also checks if the system has secure configurations like secure boot or TPM enabled. So this checks the hardware firmware levels of devices. It identifies outdated or vulnerable firmware that could be exploited by low level attacks persisting beneath the operating system. That's what it does, hardware and firmware assessment. So, how it is helping us? It covers blind spots below operating system because traditional scans focus on software and operating system, but that's not enough. Attackers increasingly exploit firmware weaknesses that survive OS reinstalls. It defends against stealthy attacks. Stealthy attacks, firmware level attacks, are persistent and hard to detect, but it is there. Assessment helps spot outdated or vulnerable firmware before it's abused and validates hardware security readiness because it ensures enterprise devices are using modern protections like secure boot, BitLocker with TPM and credentials guard. And compliance, of course, NIST, CIS, and Zero Trust emphasize hardware rooted trust. Many industries require firmware hardware security checks all the time. So we have there in DVM. So let's take an example. An organization has patched Windows fully, but a batch of laptops still running an old Intel CPU microcode, which is vulnerable to Spectre V2, not the Bond one, yeah? Traditional scans Of course, misses it. Why? Because this is not DVM. So what you need? You need DVM. DVM flags those laptop, shows Intel CPU, microcode update required, and provides a remediation recommendation like apply BIOS or from Dell, right? This allows IT security teams to patch at the firmware layer, closing a critical gap attacker could exploit. So, hardware and firmware assessment in DVM extends vulnerability management below the OS, checking for insecure firmware, outdated BIOS, missing hardware security features, and driver level vulnerabilities. It is essential because attacks at this layer are stealthy, persistent, and very high impact. And finally, we are here on the authenticated scan for Windows. This is the last feature that we are exploring. If you see done, 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 the last one. We have completed each and every one. So, what is authenticated scan for Windows in Microsoft Defender or DVM? An authenticated scan is when the scanner connects to Windows system using valid credentials like local or domain to perform a much deeper and more accurate vulnerability assessment. So, what is happening? Authenticated scan through valid credentials perform a much more deeper and more accurate vulnerability assessment. So, unlike an unauthenticated scan, which only checks what's visible externally, like open ports or banners, an authenticated scan can log into the system and check actual operating system settings, installed patches, software version, registry keys, configuration policies, etc. Right, goes beyond this surface level checks. Right, so this is typically done using Windows credentials like local admin and domain account. So this performs deeper scans. This perform deeper scan on Windows system using authenticated credentials. Right, so it has the more information unlike remote scans. So how it helps? Deeper visibility. Without authentication, scans rely on banner info or open ports. With authentication, DVM checks the actual state of the operating system. It reduces false positive because it confirms whether a patch is truly missing or already installed. False positive and negatives because prevent wasting time chasing inaccurate alerts. Now, helps compliance for sure because standards like we've been talking about PCI, ISO, HIPAA require authenticated scans to prove system security, not the high level or surface level. More accurate risk prioritization because it knows under the hood. So DVM can cross-check exploitable CVE plus missing updates with real system state, helps IT teams prioritize patching correctly. Now, with the help of one example, we'll try to summarize this. There is a Windows Server 2019 shows an open RDP port. The unauthenticated scan flags RDP service might be vulnerable or CB something something. But if it is authenticated scan, the scan logs into the server, checks installed hotfixes, confirms the CVE is already applied, so the server is not vulnerable. This reduces false alarms and helps the security team avoid wasting time. Right? So, what is authenticated scan for Windows? Authenticated scan for Windows in DVM allows Defender to log into the Windows endpoint servers securely to run a deeper, more accurate vulnerability and configuration assessment. It's essential for reducing false positives, meeting compliance requirements, and ensuring you have real actionable vulnerability data. With this, we have completed all 16 features and capabilities. I hope it was informative and thank you for watching. You guys have a wonderful day.